You're listening to the N2K Space Network.
Some of the news this week about cuts and delays to space programs have been a bit heavy. But it's Friday, so maybe let's take a look at more positive news to round out the week, shall we? Developments about new space facilities are always good to hear. And in fact, a new testing facility is coming online in the UK soon, and it's just signed its first customer. So let's take a look at what's going on there.
T-minus 20 seconds to LOS egress. Go for deploy. Roger roll.
Today is May 12th, 2023. I'm Maria Varmazis, and this is T-minus. Airbus signs with the UK's National Satellite Test Facility. Say hello to Space Force's COMSO. AT&T to lease spectrum to AST SpaceMobile. Good news from Rocket Lab, too. And my conversation with Sita Sonty, who leads the commercial space team at Boston Consulting Group. She walks me through the use cases and benefits of edge computing in space. All this and more, stay with us. Now let's get into today's Intel briefing. So back to the good news about added capacity and new facilities for space programs. Two bits of promising news on that front. The UK's National Satellite Test Facility, or NSTF, at the Harwell Campus Space Cluster in Oxfordshire has a new customer. Their first, in fact. Airbus Defence and Space UK will be testing their new Skynet 6A, and yes, Terminator fans, it really is Skynet. It's a secure military communications satellite, currently being built at 2 Airbus UK sites. And as for the NSTF, it's a new facility built in the hopes of giving UK-based space companies a large-scale testing site on home soil without needing to ship spacecraft over to the US or to Europe. With commissioning expected in the second half of this year, the UK's NSTF, along with its vacuum test chamber, the largest in the UK, as well as an electromagnetic chamber and a vibration facility, should all be fully online by next spring to begin testing the Skynet 6A to see if it will be able to withstand the rigors of launch and travel to space. And the other bit of facility news is stateside, and in this case, it's a commercial office, but still. Space News is reporting that Space Force is opening a new commercial services procurement office in Chantilly, Virginia, and it'll be known as COMSO. This new COMSO office will be in charge of working with the commercial space industry to buy its services for national security purposes. Things like satellite communications and data around space domain awareness are going to continue to be of interest, of course. But weather and advanced Earth imagery are also of interest as well. And if you're thinking that there are already a few agencies at Space Force that do this kind of thing, like the Space Domain Awareness Data Marketplace or SpaceWorks, you're right. And they're all going to become part of COMSO. The interest from Space Force in what the commercial sector can offer is there, says Colonel Richard Knisley, who's head of the Commercial Space Office at Space Systems Command. But it's an open question if Space Force's eyes are bigger than its budgetary stomach, so to speak. Expect more on this after the new office officially opens on June 7th. But in the meantime, yes, Virginia, there is a COMSO. AT&T has filed with the Federal Communications Commission to lease spectrum from AST SpaceMobile to connect smartphones in the U.S. to its planned constellation. The companies need FCC approval for wireless transmission between a phone and a satellite. AST SpaceMobile demonstrated its first voice call from a smartphone via satellite last month, and it plans to work with mobile network operators and use their spectrum to provide satellite-to-cell service. AST also plans to launch its own commercial satellites in 2024. And some business earnings news now, and Rocket Lab has reported a 35% surge in revenue during its Q1 earnings call. The Launch Services and Space Systems Company achieved its fastest turnaround between launches this quarter, lifting off from Virginia and then New Zealand within 7 days. Rocket Lab CEO and founder Peter Beck says the company has seen an increase in launch bookings for Electron launches in 2023 and beyond, from new and returning customers across government and commercial sectors. The company says it is still on track with the development of its larger Neutron launch vehicle for large spacecraft and constellation deployment. Continuing now with investor news, Intuitive Machines reported in its first earnings report that its IM-1 mission is expected to be at the launch pad in, quote, mid to late Q3. The mission will attempt to land their Nova-C spacecraft on the lunar surface, potentially making it the first totally private company to do so, if it is able to beat Astrobotics to the moon, that is. Intuitive Machines says it's currently assessing the landing spot on the moon for a follow-up mission. Canadian satellite company Telesat told investors that the company hopes to deploy its Lightspeed constellation in 2026. The company has experienced significant delays with the project and says it will deliver a more definitive timeline of deployments once it secures all of Lightspeed's funding. Telesat generated a small amount of revenue coming from U.S. military demonstration projects using Lightspeed technology. The mysteries of Mars continue to be revealed by NASA's Perseverance rover. New images from Percy seem to indicate that there was a stronger, deeper river on the red planet than previously thought. NASA believes the river was part of a network of waterways that flowed onto Jezero Crater, the area the rover has been exploring since landing more than 2 years ago. Scientists hope that these riverbed environments could help them in their efforts to seek out signs of ancient microbial life that may be preserved in Martian rock. And our heartfelt congratulations to Skyroot for being recognized as Young Turk Startup of the Year at CNBC TV 18 India Business Leader Awards. Now, Skyroot is among some of the commercial space companies in India that Prime Minister Modi is hoping will increase the country's share of the global launch market. We'll be discussing India's space policy next week in our Deep Space episode with guest Namrata Goswami, so join us next Saturday for more details on that. And it's been branded as the new space race, and both sides are openly watching the other. Chinese scientists have reportedly been analyzing SpaceX's Starship launch frame by frame, and the U.S. has been analyzing data from China's recent spaceplane flight, which seemingly performed multiple recaptures of an object it released into orbit. Unknowns abound. But what we do know is that both countries are advancing humanity's knowledge and understanding of the universe. A little healthy competition is good, right? And you can read more about those stories and lots of others that we've mentioned in our selected reading section of our website at space.n2k.com. And that concludes our briefing for today. And stay with us for our interview with Sita Sonty from Boston Consulting Group as she talks us through edge computing. And hey, T-Minus crew, tune in tomorrow for T-Minus Deep Space, our show for extended interviews, special editions, and deep dives with some of the most influential professionals in the space industry. Tomorrow, if you want to hear my full interview with Sita Sonty from the Boston Consulting Group as she walks me through edge computing in depth, definitely tune in. Check it out while you're mowing the lawn, grocery shopping, folding laundry, or driving your kids to the game. You don't want to miss it. I know many of you listening heard what today's interview is about and maybe don't want to admit it, but you've heard the phrase edge computing and you know it's important and transformative, but maybe you don't quite know as much about it as you'd like. It's okay. You're not alone. Let's get a comprehensive look now at what edge computing is, how it works, and most importantly, why it matters for anyone interested in fascinating new applications of space technology. And we're going to do all of that with an expert who knows this technology well.
This is Sita Sonty, Partner and Associate Director and Global Commercial Space Lead for Boston Consulting Group. I work out of the DC office, and we are really proud to be growing our practice in serving our clients in the civil, commercial, and national security space domain, as well as our clients outside the space domain who want to get in and want to know how to do it right.
Sita, you have a lot of expertise across the space domain, and one of the things that we've covered a bit in the show that comes up a lot and I'm really personally curious about is edge computing. So let's just start very high level. Please explain to us the concept of edge computing in the context of the space domain.
It's a great question. When we ask about what does edge computing mean, how is it different from the other forms of computing, and what does the application in space actually mean? What kind of different results can that yield? So simply put, it's when networks or devices that enable connectivity are located near or at the user. So I'll give you an example. If you're riding in a taxi and you tap your iPhone to that little square device, that square fintech device that we've all become so accustomed to using, that is an edge computing device because it sends and receives data and it processes that data. It analyzes, all right, is this a valid method of payment? And can I send and receive this payment in real time for live operations quickly so that the user who is at the edge in that moment can send, receive, transaction complete, I go. Mm-hmm. That is, of course, an example of edge computing on Earth or potentially in a mobile vehicle. However, I want you to imagine trying to perform that kind of transaction, let's say in the Galapagos Islands. Not likely, right?
No, a little challenging, yeah.
A little challenging. Performing that kind of transaction, and let's consider them simple edge financial transactions in remote terrestrial locations. It's actually exceptionally challenging. The reason being, the device that you're using in your hand, maybe it's your phone, and the device that you're connecting to or that's conducting that edge processing, the square device, if you will, those are actually sending and receiving signals through a cellular network, terrestrial fiber network, and or sometimes Wi-Fi. But all of that depends on your local area having some or all of those methodologies of connectivity available. If you are in the middle of nowhere, you're not going to be able to send or receive any data, much less actually process transactions at that edge. And so what edge computing in space unlocks at a very high level is that it actually is going to enable processing at greater speeds and volumes in remote locations, which is going to lead to greater action-led results or greater operations in real time. But in order to do that, it's going to leverage satellite connectivity because only satellite connectivity can reach certain geographies.
I come from a cybersecurity background, so for me, I hear this and it sounds a lot like IoT, but we don't use those terms necessarily interchangeably. Is there a material difference between what we sometimes call IoT and edge, or are they kind of the same idea?
Great question. And we actually really wanted to refine our definitions around this too. It can sometimes be challenging to discern from IoT or Internet of Things because IoT can be employed as edge computing devices. Those actual devices can perform the function of edge computing. But the biggest difference in performance, and this is key, between IoT and non-IoT device edge computing is the efficacy of the processing of the data in real time, while syncing that data to a centralized server at a time when it is more technically executable and cybersecure. So you're right. There's definitely a lot of synergies, if you will, between the two capabilities, but they're not one and the same. And it's that efficacy piece that really differentiates.
That is a key differentiator. Thank you for clarifying that.
Yeah.
There are to me, a lot of obvious benefits to edge computing. Why don't we go through some of the maybe business application benefits for edge computing?
Yeah, absolutely. So edge computing in space, again, the way we see it is it's going to improve operations for, let's say, commercial terrestrial use cases. Now, those I say commercial, but it's also going to and is expected to unlock value and perform operations for national security or government terrestrial use cases as well. The reason I like to anchor around the commercial side is, let's be honest and take a huge step back. There's been such a significant attention, both in the media and, let's be honest, in financial markets, placed towards the space industry. And that's driven up the valuation of key technologies and key companies and key offerings. But part of that increase in valuation is grounded on the premise that the customer base or the general customer bases for space-based technology, whether it's satellite connectivity, Earth observation, precision navigation and timing, or in this case, edge computing in space, are going to be commercial. There was this assumption, okay, it's the commercial use cases that are going to drive and unlock this huge growth in value, because until now, space tech really serviced government customers predominantly. So part of what we tried to do with our analysis and what I'm really passionate about in our practice overall is we try to pick those apart. We set aside government and do sort of a government analysis of customers, of need, of capability, and of value. And then we look at the commercial side, because that's where you see, to your point, What are the real business impact going to be? So to answer the question, I'll focus on the business side in the commercial space, but I don't want to suggest that there isn't a huge government value creator as well.
Oh, sure. Yeah, no, that's a great point. That's a good point. Yeah.
But among the use cases, you could imagine improved IoT performance that can help like a smart remote city actually take shape. Because we've heard so much about the development of smart cities worldwide, right? And there's an increased adoption of IoT services that still require edge computing devices. But what's interesting is that some of these smart cities are emerging in places where, again, you don't have fiber laid down, or maybe not yet. You don't have enough effective cellular coverage. You don't have 5G. And maybe the emergence of these is at a slow enough pace that an edge computing and space capability can leverage satellite connectivity to deliver that solution. And I'm thinking about Saudi Arabia. I'm thinking about Ecuador. I'm thinking about Brazil. I'm thinking about places that are outside of the major metropolitan areas, but where there's been an investment and talk about creating smart cities. And so that remote infrastructure, that's sort of how I think about it. In that remote infrastructure, hospitals, schools, etc., they can actually leverage connectivity on a satellite bus, and they can perform those transactions, processing data from devices in those locations, leveraging satellite connectivity, and then send the data back to remote devices with improved latency. So that's sort of an example of an aggregate set of solutions from an infrastructure standpoint that I think is really powerful.
You mentioned that there are a lot of benefit for government use, and I think you sort of just touched on that, but were there any other use cases for government use that you'd like to mention?
Oh, for sure. You'll think I'm really geeky, but I have a list of like 20 odd use cases on the government side, 20 odd use cases on the commercial side, because I keep trying to assess like, what can you really do with this technology? And then commensurately, you then have to assess, well, how much investment is required to get there. But setting that aside on the government, in fact, the remote infrastructure play, interestingly, is kind of an example of a local or civil government application, because quite often it's an investment that's made not only by those who are manufacturing the devices who are looking for that edge compute and space capability, leveraging SATCOM, but it's also the local governments who are investing in the establishment of that remote infrastructure as well, right?
Mm-hmm. Are we able to support what's needed, or are we still trying to get there?
So this is such a great question, because this is one of the key takeaways. I'll just answer it briefly, but one of the key takeaways is supply is not going to be able to meet the demand. Meaning we don't have the infrastructure established in enough scale, at enough scale, in enough depth, with enough flight heritage and supply chain heritage and customer heritage yet to be able to say, yes, we can actually meet these use cases and we can create and unlock so much value. We can unlock value for the mining industry by, enabling a mining drill that's loaded with sensors, because you have sensors that are on, there's so many ground-based sensors that are used for business insights. Well, if that sensor wants to detect like a sulfide oxide level in a mineral ore, but that requires real-time detection. That real-time detection and analytics that can actually help maximize the efficiency of the treatment of that ore absolutely depends on connectivity that is not available through 5G, through cellular, or through fiber in a lot of these remote mines. Think of the value creation for the mining industry. But what's interesting is we do not have enough suppliers who are able to create and field that capability just yet. Some of the implications which we get into in the piece, but which I often think about as how we frame value creation for the space economy and for the terrestrial economy through some of these use cases, is what can governments do? Government agencies, as they look to procure these capabilities. What can investors do? Investors should be paying very close attention to the edge computing and space supply market. And when they do, and if they read our piece, they may deduce that there aren't enough providers who have enough capability at scale yet, and they won't by 2030 unless those who have spoken about creating edge computing capability at various chains along the tech stack receive more investment of that influx in order to unlock that value. And number 3, what can customers do? Because we think of investment traditionally as the financial institutions, right? The capital, the VCs, the private equity, the institutional banks. But customers can also drive some of that adoption curve by making their own strategic investments and actually integrate it into their own tech roadmap through services procurements. And so I'm envisioning a world where a Glencore or another mining company says, you know what, you're right, that has the potential to unlock tremendous value and improve our efficiency of operations in real time. Let's see what it would require for us to invest in that capability. We don't need to build our own processor on board a commercial space station, but maybe we can actually rent it. Maybe we can use a piece of it, some of that capacity. And in order to do so, we would need to invest our own CapEx in that regard. And I'll just, at least offer this parting shot on edge computing in space. And I'll put it again in a broader context, which is every time I'm at a conference or I read an article, there's all this talk about democratizing space or democratizing access to space-based technology. And it's not happening yet. And so for me, there's actually almost an ethical imperative to unlock access to these kinds of capabilities to more and more and more remote locations for more and more remote functions. Because if that's actually going to increase the likelihood that the quality of education that students in remote locations around the world receive, or the quality of medical care that hospitals are able to deliver because they're serving that real-time data transmission, the better quality of disaster relief, especially in light of the increase in uptick in weather-related events, that kind of ethical imperative is just really meaningful to us. So that's certainly what motivates us to continue to try to unlock this value and try to posit it in quantitative terms.
I should also mention, Sita and the team at Boston Consulting Group have published a research paper on edge computing that you can read on via satellite. The paper's name is Size of the Prize: How Will Edge Computing in Space Drive Value Creation? So definitely head over to our friends at Via Satellite to read more there. And as we often do after our Friday shows, we published the full interview with our experts on our Saturday special edition that we call Deep Space. There's more to edge computing in this conversation with Sita, a lot more. So if you'd like to hear more, make sure to tune in to tomorrow's show. We'll be right back. And welcome back. They're not impossible odds, but dang, the chances of your house getting hit by a meteorite are, well, depending on who you ask, 1 in 765 million or 1 in 840 million. But they're not zero. And often when there's a mysterious explosion of some kind, folks are quick to blame a rock from the heavens, only for that idea to be quickly debunked. But it does happen. And it did on Monday in Hopewell Township, New Jersey. Police there responded to a call from Susie Kopp, who found a warm, grapefruit-sized rock on the floor of her father's bedroom and 2 holes in the ceiling. That's when the police knew it was time to get their friendly neighborhood physicists on the phone. Scientists at the College of New Jersey worked with a meteorite expert from Rutgers, and after checking out the rock's composition with an electron microscope, yesterday they confirmed the rock was stony chondrite and indeed a meteorite, likely a stray from the inner solar system asteroid belt. Given its origin, the scientists suspect this meteorite is a mere 4.5 billion years old, give or take. Shannon Graham, assistant professor of physics at the College of New Jersey, told the Philadelphia Inquirer, "It's basically leftover debris from the formation of the solar system, so it's pretty cool." So this bit of rocky debris made its way to Susie Kopp's dad's house and crashed through the roof into his bedroom. And remember how I said there were 2 holes in the ceiling? That's because after the meteorite impacted the hardwood floor, it bounced so hard that it made that second hole in the ceiling. And thankfully, nobody was home at the time of impact. But the chances of this happening, wow. Perhaps they should get a lottery ticket just in case. And that's it for T-Minus for May 12th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. And we'd love to know what you think of our podcast. You can email us at space@n2k.com or submit the survey in our show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazis. Have a wonderful weekend.